and not just add management back in the same old fashion, but try and move the focus of management to a fundamentally higher level, to allow our customers, you, IT, to start managing more and more in terms that are meaningful to the end customer. And in fact, to allow as far as possible for the end customer himself to directly manage his environment. In other words, express management in terms of application service levels that you're trying to achieve, and allow you to work in those terms, not in terms that are appropriate for the plumbing down below. So we believe that we can take virtualization and extend it all the way up through existing applications, but also have it play a very important role in supporting new scale-out applications. And as you'll see later on, we're starting to work with the new framework vendors, because as you know, by and large, new applications are no longer being written to the classical operating system. People, by and large, aren't writing directly to the Windows APIs or to the Linux APIs. They're writing to these new frameworks. And when you look at these new frameworks, it's actually very difficult from the programmer's perspective to even see where the operating system is. It's hidden way down below there. And that gives us great opportunities to work with framework vendors to allow them to pass us information about the behavior of the application that allow us to do even more things in terms of high-level, service-level management, providing easier ways of dealing with these applications. So if we're trying to get there, when you look at where we are today, virtualization is basically the only viable strategy for getting there in a series of evolutionary steps. And this is true of anybody. This is not necessarily a VMware point. We need some way of basically encapsulating existing applications, wrapping that complexity up, being able to treat them as black boxes, and start sliding in these new capabilities underneath in terms of the underlevel hardware building blocks, the new substrate of software, the security, the compliance, etc. The alternative is we throw all the applications away and start rewriting again. A lot of people come to me and they say, you know, we would like our IT, our data center, to look more like Google's data center or you know, whatever. And what they don't realize is Google is able to achieve its levels of scale by having a set of very highly specialized, purpose-built applications. They didn't start with today's applications. If you're starting with today's applications, you've got to go through this step of encapsulation, and that means virtualization. And the good news is we think we can lay out a journey here whereby we put this new substrate in a non-disruptive way, we encapsulate those existing applications, and we extend them going forward to these new programming frameworks that will kind of give us the best of both worlds. And it's for this reason that we're taking the step of taking our current technology and fundamentally reworking it into something that we call a virtual data center operating system. This is a category name. A lot of people talk about this also as the meta operating system. But the notion is there's going to be a new layer of software that provides that aggregation and mediation to the underlying hardware resources, provides that point of insertion for policies and control, provides the information to do these higher level management functions. And we firmly believe that, again, whether you get it from VMware or not, you will, over the next several years, need to choose what is going to be your virtual data center operating system or your meta operating system. And if you aspire to take your IT operations forward to fundamental, greater levels of efficiency and control and flexibility with existing applications, then you're going to need to have a strategy for doing this. And we intend to offer you a strategy going forward there. And so we will be introducing a new generation of products. And this is the first time that we're using this name in public, which will be the VMware vSphere system. So this will be our name for our new generation of virtual data center products that will gradually replace our existing generation of virtual infrastructure products. So VMware vSphere, and at the conference today you can go to a lot of preview sessions where you can basically learn more about what you can expect to see in the vSphere generation of products that will start to ship this year, 2009. Now, digging down a little bit in the vSphere architecture, and as I said, if you come tomorrow and listen to Steve, he'll give you a lot more detail on this. You can think of this to some extent in classical operating system terms, in the sense that it is designed to be a system that coordinates resources and provides services to applications, and as such has places where you can insert extensibility, where you can put in modules that know how to do specialized things or deal with various specialized capabilities of the underlying hardware resources. So in the vSphere system, there is a set of interfaces that face downwards towards the underlying hardware resources for compute, storage, and networking. There's a set of interfaces that face upwards towards the application loads. And in our model, an application load means the application and all of the complexity surrounding it, the middleware, the operating system, etc., and provides services to those application loads. And we will allow things to be, and encourage, in fact, things to be plugged into this architecture. So in the compute space, there is basically a set of extensions to allow more efficient usage of the computing resources, either in an individual processor point of view or from a distributed processing point of view in a local area setting and eventually in a wide area setting as well. Coordination of storage resources, where we can basically have ways of allowing our vSphere layer to signal to the underlying storage layer what it would like to see happen, and conversely allow the storage layer to signal up what it's capable of doing, allow the two to then negotiate to do things in the most efficient way. So if the storage layer, for instance, says, hey, I can do block copies, then the system won't bother to do that. It'll just say, okay, take this big block here and copy it over there, and the storage arrays will do it. Or if you can do deduplication or whatever, that allows that intelligent exchange of information to happen. Similarly with the networking world, where we can basically know what the network is capable of doing and converse, and as a result use it appropriately. At the application level, with a set of services, again, as we say, because we've encapsulated these workloads, we can start to slide in things like data protection, clustering, a lot of things that we can do in the general security space, where I'm using security very broadly here to include compliance. So this provides a natural insertion point. One of the interesting things of building a software mainframe, speaking figuratively here as opposed to a hardware mainframe, is because of the way virtualization is done, we get the opportunity to introspect on literally every event that happens in that environment. We can, if we want to, literally see every instruction, every memory reference, every packet flow that happens in that entire environment, and offer people in a controlled way to basically hook in and receive an event stream at any level of granularity. We're actually starting to see people use this for debugging purposes, because we can actually produce, if we wanted to, and if you have enough storage to record it, literally instruction trace for the entire data center. Think about doing things like intrusion detection or security fault analysis, etc. Incredible place where you can get this very rich stream of information surfaced in an appropriate way to do all sorts of interesting security compliance, security and compliance functions. And it's for this reason, this is one of the strong reasons that we think that people will move to a virtual data center operating system architecture, is not only because of the efficiency and aggregation that you can achieve, but because this can become a fundamentally more secure and reliable infrastructure. Because we have this comprehensive view of being able to aggregate and analyze the event stream in the environment. And then finally, scalability works well because we can now treat resources in a completely fungible way. You'll see a great example of this in a few minutes when I bring up one of our guests here to do a demonstration, giving a very real example of what it means to have a single giant computer rather than a bunch of individual server machines. So vSphere, the virtual data center operating system, provides that basic aggregation and the insertion point for security and compliance. But on top of that, we need to have management as well. So we are similarly restructuring our management products into new generation called the vCenter Suite.